Good morning, ladies and gentlemen. This is 5.2 interior and exterior angles of a triangle. The interior angle of a triangle adds up to 180 degrees. If you didn't know that, don't worry, now you do. So that means that angle A plus angle B plus angle C all equal 180 degrees. That's just what that means. In a triangle, an exterior angle is a supplementary angle to the interior adjacent angle. So that means that B is our supplementary angle. So you remember our justification, which was SAT, or supplementary angle theorem. B is just supplementary to angle A. So this just means that A plus B, angle A plus angle B, will equal 180 degrees as well. An exterior angle of a triangle is equal to the sum of the interior, or the two opposite angles. So just to clarify, an exterior angle of a triangle is equal to the sum of the two opposite interior angles. Our new justification will be known as EAT, Exterior Angle Theorem. Here we have angle A plus angle B is actually just going to equal the same as angle D here. Because we know that angle A plus angle B plus angle C equals 180 degrees. But angle C and angle D will also equal 180 degrees. If we look at all three exterior angles of a triangle, we know that they add up to 360 degrees. So this means, in this case, our angle A, angle B, and angle C here are going to add up to 360 degrees. Okay, that's all that means. This first example I forgot to mention is known as sum of the angles in a triangle theorem, or you could call it SATT for short. Recall, triangles can be classified by side lengths or angles. In this case, if we're classifying by side length, an equilateral triangle means that all sides are equal, which means that all angles are equal. And if all the angles are equal, that means that they're going to be 60 degrees. If we have an isosceles triangle, that means that two side lengths are equal. Which also means that two angles are equal. If we have a scalene triangle, that means that no side lengths are equal. Which also means that no angles are equal. If we're classifying triangles by angles, an obtuse triangle means that one angle is greater than 90 degrees. An acute triangle means that all angles are less than 90 degrees. And if we have a right triangle, that means that one angle is 90 degrees. Let's move on to some examples. We need to determine the value of x and justify our answer. Well, if we know that all interior angles add up to 180 degrees, we know this plus this will equal 180. So if we have 42 plus 76 plus x equals 180, we just need to collect like terms and solve for x. So I'll have 118 plus x equals 180. I have to move the 118 over. I'll get x equals 180. Subtract 118. And I get x equals 62 degrees. And this is sum of angles in a triangle theorem, or SATT. Next example, if we're looking at this angle here, well, that looks like our other theorem that we used, which was interior or exterior angle theorem, which meant that if I go back 2 slides, right here we see it very clearly, our exterior angle theorem. We have A, B, and then that is equal to D, and we can see the equation down below highlighted. So that means that A plus B is going to equal D. So if I go back, we know that 84 plus 37 is going to equal X, which means that 121 equals X. Oh, I forgot degrees. 121 degrees equals X, and that is our exterior angle theorem. Next, we have 2 dashed lines right here and here. What this means that this is an isosceles triangle. So we have 2 side lengths. This side length, these 2 side lengths with the dashes are equal in length. What this also means, the opposite angles of those sides will actually be the same. So if those side lengths are the same and I find the opposite, it's over there, and I find the opposite for that, it's over there, that means that this is going to be 48 degrees. Now I can actually use the sum of the angles in a triangle theorem, or SATT. So what this means is I have 48 plus 48 plus X is equal to 180. So then I add my 48 plus 48, and I get 96 plus X equals 180. I subtract 96 from 180 to get what X is. I get X equals 84. And I forgot degrees. And my justification was SATT, because we used our properties of an isosceles triangle, and then we used our sum of interior angles of a triangle theorem to solve for X. All right, next example. Our first example here, we have 3 angles here, here, and here, and no numbers given. However, if I go back, there we go, I can use my sum of the angles theorem to solve for X. So I know all the angles are going to add to 180. So if I go back, so I'm going to have 180 is equal to X plus bracket 3X plus 15 plus 2X plus 3 and bracket. I can drop the brackets and start collecting like terms. I'm actually going to use a red pen or a different colored pen to underline this. Let's use green to circle all the X's. So I got X here, X here, and X here. That means I'm going to have 1 plus 3 plus 2, so 6X. And then I'll use red for the constants of 15 and 3. So 15 plus 3 gives me 18, so plus 18. And then I have 180 left over, so I'm going to switch back to my blue. My 180 is on the left still. Okay, so I have 180 equals 6X plus 18. I move the 18 over and subtract, and I get 180 subtract 18 equals 6x. Then 162 equals 6x. Divide both sides by 6. You get 27 degrees equals x. And my justification for this is the sum of the angles inside a triangle theorem. Our next case, we're given a number here. We have an angle here with a variable and an angle here with a variable. But we can't use our sum of the angles inside a triangle theorem. If I go back to this page, we see very clearly it's set up very similarly. We have an exterior angle, which means our exterior angle theorem tells us that angle D is going to equal A plus B. So the two opposite interior angles are going to be equal to the exterior angle. So if I go back too far, there we go. I need to set this up so that I have 67 as my first angle, plus x plus 14, and that's going to be the same as 2x plus 39. And once you have this set up, you guys already know how to do this. However, I'll work through it with you just to make sure that we get everything right. So I have 81, because 14 plus 67 gives me 81 plus x equals, well, I still have 2x over here, and plus 39. So I need to move some stuff around. If I move the 2x over, I'll get x minus 2x. If I move the 81 over to the left or to the right side, I get 39 minus 81. Collect like terms, I have negative x equals negative 42. Divide both by negative 1, I get x equals 42. And my justification for this would be our exterior angle theorem, EAT. Okay, that's everything for this set of notes. If you have any questions, make sure you ask, and best of luck.